Welcome back. Last two properties for exponents and logarithms. So properties of exponents and logarithms take two. Last two to go. Should be 2 minutes or less. So definition of rational exponents. This obviously is just an exponential rule. And we've done this one, but it was after we did all of our properties. So remember, this is rational exponent. That word rational just means fraction. So this is when you have a fraction exponent. So the 1/2 power or the 3/5 power, any kind of power like that. Remember that this is transformed into a radical with a root of n and an exponent of m, which can be written like that. Or you don't need the parentheses and it means the same thing. So for example, if you have 9 to the 2/5 power, this is the same as saying the 5th root of 9 squared, or whoops, let's put that's not really, so just to model it after that, of the 5th root of 9 and then that squared, or the 5th root of 9 squared. Now remember, in here we'll just do one more example. If I just have square root of, let's say, 7, this is equal to, remember, square roots have a root of 2 and an exponent of 1. So this would be equal to 7 to the 1/2 power. Okay, so square roots, the exponent is always a half. Okay, so last one here, last property. And this is, again, just for exponents, definition of negative exponents. So here, negative exponents. So remember, negative exponents do not make your numbers negative. Negative exponents make reciprocals. So if this is really over a 1, then this becomes 1 over a, and the n then, or the exponent, turns positive. Okay? If we started out as a fraction, let's say, with a negative exponent, then this becomes a to the positive exponent. Technically, it would be written over a 1, but because anything divided by 1 is itself, we don't really need to write this in, and I can erase that and just leave it as a to the n. Remember that this also works for fractions, so if I have a over b to the negative n power, I flip my fraction here, b over a, and I change my exponent to be positive. Okay, so that's definition of negative exponents. So one thing I just wanted to do was practice some of our log properties, since this is one of the first times you've been seeing those. The exponent properties, hopefully, we're a little bit more familiar with. And you have had some practice with those. So I just want to do one quick example, just using some of these log properties. So let's just say I have what are some different ways we can represent log 100. Okay, so there's a bunch of different ways we can represent log 100. So remember, this log 100 is really log base 10 of 100. So how many different ways can we represent this? So think back to all those properties you just wrote down. Properties of logs, the definition of a log, the product property, the quotient property, the power property. We can represent this log 100 in so many different ways. So on to the next slide, let's look at a couple. So log 100. So one way we could represent it, let's say we use definition of a log. Right? So if log 100, then, so log 100 would also equal 10 to the x power equaling 100, because I can use definition of a log and get, come on, trying to put a colon there. I can use the definition of a log and get this as another way to represent log base 10 of 100. If I use the product property. Product property. Then log 100 could equal log 10 plus log 10. Because the product property says that if I'm adding two logs, I multiply the numbers. 10 times 10 is 100. Or log 100 could equal log 10 plus log 5. So now I'd be at 10 times 5 is 50, so plus log 2. Because now I have 10 times 5 is 50, times 2 would be 100. So there's another way I could represent log 100. How about quotient property? So quotient property. I could do log 100 is equal to log 100 minus log 1. Because remember, subtracting means I divide, so 100 divided by 1 would be 100. Or I could do log, let's say 200 minus log 2. Now that's 200 divided by 2, which would be, again, 100. So I could use the quotient property. Let's see, what else? Log 100. So what else could that equal? Log 100, log 100. How about using the power property? Okay, power property. So log 100 could equal 2 times log 10. Because remember here, this 2 in front is really an exponent. So this is the same as saying log of 10 squared. And 10 squared, we know, is 100. So this is another way I could write log 100. What about any others? Can you think of any others? They might be in a do now come tomorrow morning.